I want to introduce Evan Kuklinski. This morning we shouted out ARTICA, the sponsor, title sponsor of this whole event. I also want to shout out CINA, TEDx. Thank you for being here. Thank you for being a part of this big event this week. I want to welcome to the stage Evan Kuklinski from ARTICA. Come on up, Evan. This man drove a machine here 36 hours from Portland, Oregon. He is well rested. He's ready. He looks great.
Through the night.
Through the night. Evan, you're on. Thank you.
Hello, everyone. On my first day of sensors and instrumentation in college, my professor came in and he didn't introduce himself. He didn't say his name. He just came in and says, every sensor you will ever use is loud, lazy, and lying to you. They're loud because no matter how good you are, there's always going to be a noise, some noise in a circuit. They're lazy because between when something happens and when you sense it, there's going to be some delay. And they're always lying to you because there's always some built-in error, no matter how good the sensor is from the factory. And I laughed because we literally use sensors in everything that we do. Every part of our life uses sensors. From the accelerometer in your phone, to the thermostat in your house, to the ultrasound that showed me the first photo of my baby. We are transducing physical parameters, physical properties into electrical signals, and we are doing data with them. And they exist across all industries all the time. That lesson really stuck with me. And I laugh because no matter what, we have these sensors in our lives that we rely on, and they're loud, they're lazy, they're lying to you. And my professor's voice rings in my head every day. Furthermore, once I got into my career, I started asking a harder question. I started asking, not just is this measurement accurate, but is this measurement even real? Is the metric we're looking at the thing we should be looking at? Before I was in cryotherapy, I was in tech, and we built devices in your hands. These little devices that we take for granted, our phones, our tablets. Inside of each of those devices are processors that get really, really hot, like boiling water hot. And it was my job and my team's job to figure out how to keep them cool in your hands. And every day we were left with a question that was easy to ask but hard to answer. How hot can an object be before it burns your hand? Seems like a temperature problem, doesn't it? It's not. Temperature is just one part of that equation. So we were left with this conundrum, and we had to create a unit, a standard that didn't exist. How do we measure, how do we classify how something feels, not just what temperature it may be at? So we created something called a MOS score. Stands for Mean Opinion Score. We asked thousands of people to hold different objects at different temperatures and let us know when they went from comfortable to warm to please get me out of here, I don't want to do this test anymore. And from there, we were able to distill down this number, this metric, that would help later define the industry and allow us to classify objects about how hot they could be. Aluminum has one MOS score. Plastic has another MOS score. You may not understand this, but intuitively it makes sense when you think about walking it from from a hardwood to carpet. Same room, same temperature. One feels warm, one feels cool. This is not your imagination. This is the effect of conductivity and thermal resistance. So we had to have a way to distill this, and the only way we could do it was creating our standard that actually made sense so we could classify objects. Here's another example. 300 years before I was at Intel, there was a young boy, 15 years old, from Danzig, and he lost his parents in this terrible accident. It was poisonous mushrooms at family dinner, which was unbelievable. And he his guardians shipped him off to Amsterdam to become a bookkeeper. But he had other plans. He wanted to study physics, so he delved deep into physics. He also studied glass blowing, and he became obsessed with this one problem. As he traveled, he found that no country in Europe shared the same temperature scale. Germany had one temperature scale, England had another temperature scale, France had another, to the point where scientists, one from London, one from Paris, couldn't agree on the temperature of the room. Their data just didn't mesh. So this self-taught 15-year-old boy said, I'm going to solve this problem. And so he did. But he went into debt. The entire time he was buying mercury, buying alcohol, buying glass, borrowing money he couldn't pay back. He got in trouble from the law. They issued a warrant for his arrest to ship him off as slave labor into the East India Trading Company. And so he ran. And he ran from Denmark to Sweden to Poland to Germany. All the time he was creating these thermometers until when he was 28, he created a set of thermometers that agreed with each other. And he was able to have two people, remote people, have sensing that agreed with each other. And his name was Daniel Fahrenheit. He was a self-taught, runaway bookkeeper that just had one question he wanted to answer, and he cared enough about it that he worked his butt off to develop a standard that now, 300 years later, when we check the temperature in our phones, the weather, we are quite literally using his namesake. So Fahrenheit did it alone, but sometimes a standard comes from an industry that just has had enough. I don't know if you know this, but sunscreen, back before '62, was marketed on vibes. It was, all-day protection, stays on the beach for hours, good. And at one point, there was no way of comparing this marketing, right? It was a sales pitch. And so in 1962, there was a Swiss chemist, Franz Greiter, and he developed the sun protection factor, SPF. It wasn't even a unit, it had no units, had no Greek letters, it was unitless quantity, right? But it was a classification system, SPF 2 versus SPF 15 versus SPF 50. And now every bottle of sunscreen on every market, on every shelf in the world could be compared against each other and not just rely on the vibes that marketing had. You could actually understand what that sunscreen would do for you. And overnight, that industry gained more honesty. Not because the science changed, but because somebody demanded a metric that was not on a brochure or a simple sales pitch. So 2 stories, 2 people in history. 1 lesson. Standards, they don't fall from the sky. Standards exist because somebody decides they should exist. When I first got into cryotherapy, that's what I do now, I approached it like I approach a lot of things in thermal engineering. I read spec sheets, I read brochures, I read about the science. I understood the implications of the temperature ranges we were trying to get to, the physics involved, the mathematics, right? And sitting back and looking at what the landscape was showing me, something didn't smell right. Based upon what I could analyze, I was looking at numbers that if they were true, thermodynamics was taking a vacation on those days. It was not in the room. And so I asked myself, I guess what I want to say is I want to be careful with that comment because I don't think that the people writing brochures are lying. I just think that they do things that marketers tend to do. They find a simple variable that is easy to consume, that is easy to talk about in a sales pitch. They print it on the paper next to flashy lights and say, ooh, look at this. And to some extent, that's okay. But at some point, we have to understand that it's not that their measurements were wrong. It's that their measurements were incomplete. Temperature is a variable in a string of equations, one variable in a string of equations, that paints a larger picture about energy and how it works in our body. And when an industry takes one variable and regurgitates it to you, that's not a standard, that is a sales pitch. So what I'd like to do now is be a little honest, and I'll be quick, but red light therapy, interestingly enough, had a similar problem. They don't sell red light beds based upon the power of the bulb, right? They sell it based upon how much energy is being absorbed or at the surface of the skin. That's the ideal metric, right? It is not a brochure metric in a sense. It has to be measured at the source. It has to be measured, and what it is it's the amount of unit energy over centimeter squared. So they called it irradiance, milliwatts per centimeter squared. Here's the beautiful thing about thermodynamics, though. Energy doesn't care about which direction it's going. You could push it in, you could pull it out. It's the same math, same units of measure. If we can measure milliwatts per centimeter squared irradiance into our skin as an energy, we can also measure heat energy out of our skin in terms of heat flux. It is the same math, it's just in different directions. So, what I'd like to suggest here is that we take a closer look at how cryotherapy is affecting our body. It's affecting and how much energy is actually being extracted from our skin. Several years ago, we had a concept, and over the past couple months, we started working on it. But the idea is to bring together 3 aluminum spheres of known mass, known volume. The simplicity of this is actually part of its value. And each sphere has a temperature sensor and a heater inside of it. We heat the spheres to known temperatures, and we put it into the chamber. The chamber then cools them down, and we measure how fast that happens. And by measuring how fast it happens, we can calculate out heat flux. I call this my emotional support heat flux capacitor. This little device can then be used to classify cold or hot machines, and it actually doesn't really matter what medium we can get fancy with it if we want to use it in water as well. But the point is we're trying to ask ourselves not just what temperature this is, not just what flow rate it is. We're trying to ask ourselves what is it doing to our physiology? And furthermore, when we look at scientific studies that use devices that have been built, especially in cryotherapy, in the past, they've had to classify them by temperature zones. In this temperature zone, this happens. In this temperature zone, this happens. In this temperature zone, this happens. If you get rid of temperature, or let's say not get rid of it, but combine it into a heat flux term, then you can actually classify the physiological effects to the flux. And furthermore, then you can classify the physiological effects to the classification of the unit. Class A does this, Class B does this, Class C does this. And the beautiful thing about what happens then is now we get to talk about things like features. We get to talk about things like service, about aesthetics. And you don't have to ask whether or not this device is going to provide the therapy you want. You can actually look at its classification. So I want everyone in here to do something for me today. I want you to think about your little corner of wellness. I want you to, whether it be hyperbaric, whether it be sauna, compression, hydrotherapy, whatever it may be, whatever you operate, whatever you use to treat people, I want you to ask yourself, am I measuring what matters? Because what you'll find is that the people that ask that question, you may even know the answer. It may be that you are measuring the correct thing. And that's great, that's beautiful. Show us how you did it. It may also be, I don't know. And that's even a great place to be, because that's like an open door. You don't need some PhD to show you how to do it, especially in the world of AI. You don't need a grant or a lab. You don't need me. You don't need, Fahrenheit was a runaway bookkeeper with a glass tube, you know? All you have to do is be persistent in the question. Some of you may build it. Some of you may just be persistent in asking that it exists. Both are important. Builders and ruckus makers make industries. So it's my belief, and it's really the only thing I came up here to say, is that when we build the missing standards in an industry or simply demand that they exist, we can transform an industry built on marketing into one built on trust. Thank you.